So inside of the previous lecture, what we did was to finish up the abstraction of the general alpha class and then implement it for each of our three different strategies. And this is very useful because now we can focus on writing a very specific set of code to just generate the rules specific to the strategy without considering the normal, whether we implemented the logic correctly in the general case in terms of PNL computation and things like that. This also means that since we'll be using this code very often, in fact for every single strategy, we want our code here inside the utility class to be as efficient as possible. And this is a problem that we have right now, is that even for very small universe size, we take quite long to test our ideas. So we're going to do some programming to make sure that our code is more performant. To do that, let's go ahead and create a timing function. Right. So for example, let's just create an example. Let's ignore all of the code here. Right. And then we do import time. Then we say sum equals 0, and inside the loop we just add the numbers. Let me do this. And say we do something like start equals to time, result equals to some work, and equals to time. Then we can compute in the number of seconds required to complete this work. So we can run something like this, right? And we see that we did this work in just 0.005 seconds. Of course, we can make this more computationally demanding, and it will take this amount of time. But doing this repeatedly is going to get very verbose, and it's quite inconvenient. So what we want to do is to implement what is known as a decorator function. Right? If you want to know more about decorators, I think this is a great resource on real Python that explains decorators in great detail. So we're not going to go too much into it. We're just going to show you how to implement the function that we need. Right? So we're going to create a timer decorator. So this timer takes in a function and returns another function. Okay, and this function basically takes in a variable number of arguments and a variable number of named arguments. And what it will do is basically it will do this thing over here. It will then do this thing. And then in the middle, it will call this function using the variable number of arguments. And then it will return, and then it will print. How many seconds it took. Right, and then it return the results. So, for example, if I do that and I decorate this function, what's going to happen is we don't need this anymore. And then we can print the result. And let's see what we get. Okay, try this, and we will get this line printed out and the sum. So what this is doing is basically the same as, suppose we don't put this, and we do something like time me, some work, let's go to here. It's the same as doing that. Right, so for example, here I put in the work as a parameter, and instead here I put work, and here I pass in this argument. What's going to happen is this will take in some work as a parameter, and then this will basically return time diff. We'll basically return time diff, and then we will have this parameter as an argument which goes inside this, and then we'll be calling this inside of here. So this calls the result, and then it will return the result of this. So because we're calling this function, and this function returns time diff, it returns, it makes this function call, so this will be replaced with some work, and then we will return the result, but with the printed statement of how long it took to complete the statement. We're going to add another line here, which helps to make sure that the function context is correct. So we're not going to go too much into the detail here, but if you're interested, do check out the website that I just introduced. So we're going to put this inside the utility file, and now we have a good timer. So basically what we can do here is now from utils import me, and then we can go to an arbitrary synchronous function, and then we put this, and if we call some work, we would have this additional statement ahead of us. So that's very nice. Let's go ahead and continue with our code. So let's just remove this, and we're going to start to basically what do you call it? To refactor our code, that is, so that it's more efficient. But before we go into refactoring of the code, once you start to profile and optimize your code, the purpose of this is not to change the logic inside of your application, but it is more to make it performant, which means that you want to have a reference behavior just to make sure that whatever you're optimizing doesn't change the behavior of your actual system. And in order to do that, you want to be able to come back to the original system even after you made the changes. So at this point, if you do not have a version tracking in your practice, you might want to check out how to use the Git technology. So basically something like you're keeping different versions of your work. For example, if you write a paper, you might have a first draft and a second draft, and you don't want to be saving things like set 1, set 2, set 3, set 4, and then going back to the code. And that gets very troublesome over time. So the better way to approach this is through what is known as version tracking. And Git is a very powerful tool, but we will just demonstrate a particular use case that we will need. And if you're interested, you can, of course, read up more on that. So assuming you don't have any Git repository inside, so if you look at our directory, we do have a Git repository initialized already. So if you want to obtain this .git, what you can do is, assuming you have Git installed, then you can call this command, and this will create this Git repository and ask Git to start tracking our files. But for us, we already have the Git, so we're just going to skip on that. So assuming you've already initialized the repository, then you can check what branch you're on, and you're on the master branch. So basically, you only have one path or one row of code, and the only way for you to go back to your previous code is by doing something like Control-Z all the way. Of course, you don't want that. You want to have a parallel workflow. Okay, so for example, I want to make some changes to my code, so I can do something like I create a new branch. So I say this is optimization 1. So creating a new branch means that we can optionally change the branch and then change the code there. But as you can see, we're still in the master. So in order to change our branch, we can go back to optimization 1, right? And suppose to make some changes in our code. Make some changes, right? So you see the status. It says that we do have some changes. Okay, we just made a change in the utility file. So that is our timing function. But now we can basically, if you're happy with these changes, right, what we can do is to commit our code. So this is some useful changes, and of course you want to have this means I add, and then I add a message. Of course you want to have a more meaningful message, but we're not going to talk about these best practices. So suppose you just made some meaningful message, and if you see our code again, basically this you can just ignore. So now you can see we already made the changes here, and suppose we want to go back. So we're now on our optimization 1 branch, and now we want to go back to our main branch. So see what happens to this particular line, right? Once we go back to the master, we no longer have those changes, right? But they are still inside the other branch. So we can basically go between these two branches and make changes. And suppose inside this optimization branch, you've made enough progress that you're very happy, and you want to sort of port over the changes you made back to the master branch. Then what you can do is you merge the you merge the branch that you made the changes on, and these changes will be ported over here. So now you're in the master branch, and you can see that there are the changes that you made inside the parallel workflow is now ported over to your main workflow, and this is basically the use case of one of the use cases of using Git. We're not going to go much more into detail, but I just wanted to bring that up so that we can have a safer. You don't want to make some changes and then realize that your code is now buggy, and then you have to basically throw away the last 5 hours of your coding session. So that is the use case for Git, and we will be using Git and branches to make some changes in our code going forward.